Today's notes are on 3.4, medians, altitudes, and angle bisectors of a triangle. We are going to start with an altitude. The definition of an altitude is drawn from a vertex of the triangle perpendicular to the line containing the opposite side. If you would like to pause the video at this point to copy down the definition, please do so now. Remember, an altitude is perpendicular to the line containing the opposite side. Upside down T is a symbol for perpendicular. So we will now draw BD as an altitude. BD is perpendicular to the side AC. Now if this was given in the proof, suppose it said BD is an altitude, we would underline this as the given, and now because BD is an altitude, BD is perpendicular to AC. The reason why would be definition of an altitude. This is now a new reason for proofs. We must look for it in our givens, and then we can know that they're perpendicular to the opposite side. Now, altitudes can be drawn in every vertex. So we have from A, it must be perpendicular to BC, and from C, it must be perpendicular to AB. Okay? The point where these three altitudes meet is called the orthocenter. Okay, that is the point where all three altitudes meet. Looking at the next example, triangle DEF. If we want to draw an altitude from E, it will lie inside the triangle, just like our first example. However, drawing an altitude from D, there is no way I can draw a line perpendicular to EF, so it must lie outside the triangle. Here is my altitude. It will lie on the outside of this triangle. I can go ahead and extend the line EF so that the altitude lies there. Same thing here. If I were to draw the altitude from F, it would not be perpendicular to DE. So I must extend the line, and now I can draw the line perpendicular to DE. The altitude would lie outside the triangle. Looking at the next example, altitude will be a side of the triangle here. Altitude from G, drawing to HI, would be right here. I from to GH would be right here, would lie outside the triangle, would lie as a side of the triangle, and then H would be inside the triangle. So let's answer some always, sometimes, never questions that apply to altitudes. Altitude falls inside the triangle. Well, in this case it does. However, this case is different. So it doesn't have to fall inside, but it can. So this is a sometimes case. It falls sometimes outside when it is an obtuse triangle. If you need to pause this to write it down, please go ahead and do so now. The next one, an altitude can be a side. Well, it can be a side in this case right here. So that is a sometimes case. It does not have to be all the time a side of the triangle, but it can, and this is going to be a right triangle. For the next one, an altitude intersects at a midpoint. Well, can an altitude also cut the triangle into congruent segments? That is a sometimes case. Looking at this picture right here, I'm going to draw a specific type of triangle. This is an isosceles or an equilateral triangle. We will learn that later. So we're going to draw the altitude down, and it would also create a midpoint to the opposite side. This is a sometimes case. It only works in isosceles triangles or equilateral triangles. Isosceles is two or more sides congruent. Equilateral is all three sides congruent. Now a median is this picture right here. This is an altitude. It is also a median. Alright, a median is a segment drawn from a vertex of a triangle to the midpoint of the opposite side. Once again, if you need to pause the video, please do so and write down the definition of a midpoint. Median. A median, again, creates a midpoint to the opposite side. So the first example we're going to draw in the median for the same triangles that we had in the first example. Example 1. For drawing a median in, BD would be the median, so I'm going to draw a segment. Now this is going to be about the midpoint here, and you must label the midpoint as so. BD is the median, so if you were given BD is the median, as a given, underline it, because BD is the median, D is the midpoint of AC. You must say that the median creates a midpoint of the opposite side. So this would be definition of a midpoint. The next example, drawing from A, remember it goes to the midpoint of the opposite side. So I must create a midpoint here, and the last one going from C to the midpoint of the opposite side. Okay, go ahead and try these examples. If you'd like to pause it, I will put the answers up in one moment. Here's how the medians will look in triangle DEF and triangle GHI. The middle point where these medians meet is called the centroid. Okay, all medians will meet in the centroid of a triangle. Looking at our always, sometimes, never questions, a median falls outside the triangle. That will never happen. Median is perpendicular to the opposite side. That can happen, as we noticed up here in this example. The median is perpendicular and will also be a median because it creates a midpoint with the opposite side. So this happens in an isosceles triangle and an equilateral triangle. A medians are congruent. They can be. So that is a sometimes question, sometimes answer. This would be an equilateral triangle where they are all congruent. Median is the same as an altitude. Again, that is very similar to number 5. That is a sometimes question. Equilateral triangles will have the median and the altitude be the same, and isosceles triangle will have the median and the altitude be the same. Moving on to the next page. An angle bisector is an old topic that we've discussed in chapter 2. An angle bisector is a segment if it cuts an angle into two congruent angles. Okay, again we have two congruent angles if we know that a segment is an angle bisector. So if BD is an angle bisector, these two angles, I'm going to say angle 1 and angle 2, will be in fact congruent. So in the proof, if we have BD as an angle bisector, we can say angle 1 is congruent to angle 2, and the reason would be definition of an angle bisector. Okay, so drawing them all in, we have congruent angles over here and here, and congruent angles also here as well. Go ahead and continue and draw the angle bisectors for these two triangles. Here are your angle bisectors in these two triangles. Remember, angles are congruent if you have an angle bisector. One other thing I'd like to point out, this point, the angle bisectors meet in the center called a circumcenter. Looking at your always, sometimes, never questions. Angle bisector can be outside of the triangle. That can never happen for an angle bisector. Segments inside the triangle can be congruent. This could sometimes happen. Angle bisectors can be congruent in an equilateral triangle. An angle bisector can also be an altitude. This could also happen if it is an equilateral triangle or an isosceles triangle. And an angle bisector can also be a median, same with an equilateral triangle or an isosceles triangle. There, remember, equilateral triangle is a triangle of all equal sides. Isosceles has to have at least two sides congruent. Looking at everything, can the median and an altitude of a triangle be the same? This is sometimes. Again, we have a picture of an isosceles triangle with these two sides are congruent. If these two sides are congruent, I can go ahead and draw an altitude, and an altitude will be in fact be the same as a median. Okay, remember median makes a midpoint, and altitude creates perpendicular segments. What type of triangle has only one perpendicular bisector passing through the vertex? We just answered that question. That is an isosceles triangle. And what type of triangle has of three perpendicular bisectors passing through the vertex. That is an equilateral triangle. Last question, can the circumcenter be the same as the orthocenter and the centroid? That only happens again in an equilateral triangle. The last part, they will give us Rn is an altitude in one case, it is a median in another, and it is angle bisector in the third. So if we know Rn is an altitude, altitude means perpendicular. So if Rn is an altitude, we know that perpendicular segment would be QW, would be perpendicular to Rn. That means that 5x plus 60 would in fact equal 90 degrees. And then we defined x using algebra. Go ahead and solve for x. Alright, so we subtract 60 to both sides, divide by 4 to get x equals 6. Next case, we have Rn is a median of triangle RQW. For this case, a median creates a midpoint, so Qn is equal to 2x plus 12. 6x minus 4 equals 2x plus 12. And in fact, median means midpoint, so it creates a midpoint at n. Solve for x, please. In this case, subtract 2x to both sides, add 4, divide by 4, and we get x equals 4. For the last one, Rn bisects angle QRW. So now if Rn is an angle bisector, we have these two angles will be congruent, and we set those two equal 7x plus 3 equals x plus 33, and solve. In this case, I subtracted x to this side, I've subtracted 3, so I have 6x equals 30 divided by 6x equals 5. So depending on what type of segment Rn is, we get three different answers. If it's an altitude, we get x equals 6, a median, x equals 4, and an angle bisector, x equals 5. Have a good day.